Hey, welcome to your third part of your notes. You will see that this is your notes that hopefully you have the first two parts filled in. And now we're going to be down here on this page that starts with a blank chart. We're going to be talking about something called pedigrees. And you may have heard of pedigrees before. Typically with like pets, you might have papers on your dog and show that they're a full-blooded, whatever, or cat or something like that. And basically you have a pedigree, which is this big chart that helps you trace back their relatives. A lot of people think of it as almost like a family tree, but it's more in tune with phenotypes and genotypes than that. Family tree just simply says, here's my parents, here's my grandparents, here's my great-grandparents, and here's how I'm eighth cousins with somebody, okay? But a pedigree shows us certain phenotypes or traits that show up over generations. This can help a family determine whether people carry certain alleles. So even if you didn't have the allele pairs or the genotype for relatives, you can figure it out if you know some certain key things about what they look like or what their traits were like, okay, or if they had a genetic disorder. So a pedigree is really awesome. It's a really useful tool. We're going to do several activities with pedigrees. And they're really useful because they can help predict traits, namely genetic disorders in offspring. So these are pedigrees. Now let's talk about some basics. All right, this is an example down here, right down here. Sorry, let me get my stuff going. Here of a pedigree, okay, and how it would look. Without knowing anything about it, it just looks like a conglomeration of X's and circles, right? Or squares and circles, excuse me. Don't really understand some things. So let's look at basics of a pedigree, and you can see some blanks here filled in for you that you may not have prior to it. So anytime we see a square, it is a male. Okay, a square means that person on that pedigree is a male. So think about on a family tree, you would have it with terms like father or grandfather. Okay, and it would distinguish that as a gentleman, a male. Okay, on a pedigree, we have squares represent males. Circles represent females. Now, you've watched an introductory video, hopefully by now, and it's got some kind of fun ways to help remember that. I just say remember it. Males are squares, females are circles, okay? Anytime, let me get my pencil here. Anytime you see this line here connecting a square and a circle, it used to be called the marriage line. It's also been called the coupling line. I like to think of it as a relationship line. It means that they have a very close relationship, a relationship so close, in fact, that they are going to have children, okay? Now, of course, we live in a world where not everybody is married that has kids or anything like that. That's why I don't really like the term marriage line. It's kind of dated. So you might hear it called couple line or something like that. Just know anytime you see this horizontal line connecting to a male and a female there, okay, that line means that they have a relationship, in fact, that they're going to have kids by. Okay, so that's the horizontal line. Anytime you have a vertical line going down from that coupling line, okay, that means that these are offspring. These are kids, okay? So looking at this right here, this one is what we're looking at. We know we got a male and a female just because we already know these two things. And this vertical line going down shows that these three, 1, 2, and 3 here, are all their children. Okay, they're their offspring. Now, if they only had one, they wouldn't have to do these set of lines. They would only do one down like this. Okay, and so that would be their little girl, right? Their female. But when you have multiple children, you would do it like this. Okay, and that's what you would see. You would have, we can look at this. It typically runs from left to right, and this would be a boy, okay, and that'd be a girl, and that'd be a girl. Okay, you typically start the oldest kid over on the left-hand side. Now, it doesn't always have to be that way, but that's kind of how we see it. All right, so looking at this side here, a connection line to an offspring, but not connected to parents means that's a spouse of that child. Okay, so we got the original dad, the original mom, then we got the 3 children that coming from there. We got older brother right here. We got middle sister. And then we got younger sister. And here's how we see, okay, that sister, that daughter, has now got a relationship. Maybe they got married. Maybe they have a exclusive relationship here with this male. Okay, so that's her boyfriend, husband, whoever. And then we would go on from there. Let's say that they had a little boy. Okay, and we can show it like that. So in this short little diagram here, we got 1, 2, and 3 generations of this biological family, okay? And we'll look at this more in depth here in a minute. All right, anytime that we have a shaded in male or female, that means that they have the phenotype for whatever trait we're talking about, okay? So if we're talking about a disease, a disorder, when it's shaded in like that, that means they have it. When it's unshaded, not shaded over here, they do not show the trait, okay? So that's the distinguishing factor really between this being a family tree and this being a pedigree. A pedigree shows certain phenotypes that pop up over generations for a family, all right? So these are some basics. Now, some charts, the really good ones I like to think of, will have this kind of shortcut, this half-shaded. That doesn't mean they have the genetic disorder for half their life or half of their body or anything like that. It simply means they're a carrier. Now, carrier's been that term that we've been using time and time again. A carrier does not show that phenotype, right? It does not have that genetic disorder. It doesn't have that certain trait, but they have the ability to pass that trait on. So they would be like a heterozygous genotype. Okay, they're a carrier. Now, this is a shortcut that a lot of pedigrees use, but not all of them. All right, so that's what I want you to think about. All right, so this basics of the pedigree, if you need to refresh yourself on these anytime, this is a great little chart that you can always come back to now that you've got it filled in. Okay, don't worry about doing all my little drawings. Basically, just get these filled in, and you can probably put 2 and 2 together. All right, so let's scroll down to the next thing that you have in these this pedigree. And it's actually got some kind of questions about it underneath. Now, looking at this pedigree, we'll see a couple things that are distinguishing about it. It's got these Roman numerals out here, right? So you would see them like this, like true Roman numerals, like the Super Bowl is numbered after. And this is simply a way of labeling generations, okay? In some pedigrees, there's actually numbers that are used to identify each individual. We'll look at one of those here in a little bit. But in this one, it's simply got the Roman numerals. So if we were talking about it, a way that we could communicate about it without having to pinpoint on it, we could say individual 2C. Okay, and that would tell us we come down to Roman numeral 1 and 2. So we're looking at this generation. And then we would just go over the page A, B, and C. So that individual right there. Now, looking at that person, they may use numbers. I think down here in our questions actually use numbers. So person 2, 3. All right, so individual 2, 3, Roman numeral 1 and then 2. So we're looking at that one, 1, 2, and 3. And looking at that person, what can we know about them right away? First, we know it's a male because it's a square, and then it's shaded in. So they're going to have whatever trait this is that we're talking about. All right, so let's just look. Let me erase all my junk here. And let's just look at these questions. And you try to answer them, before you lean on me, all right, for it. If you need to just hear my answers. The above chart is a pedigree showing Huntington's disease, a genetic disorder in a family, okay? We can see 3 generations of this family. Huntington's disease is caused by a dominant trait. Now, that's important because we know most genetic disorders are carried on the recessive allele, but this case, the dominant one. This means the individuals who have it will have the genotype heterozygous DD right there, or homozygous dominant, right? Because it's on the dominant allele. So it's on the big D, right? So if they have that one, they have it. If this is their genotype, negative, okay? So let's just look at this for practice. Understand how to read a pedigree. Which members of the family, looking at number 1, above are afflicted with Huntington's disease? Well, the ones that are shaded. So individual 1, 1, individual 2, looking at the generation there on the side, 2, 2, individual 2, 3, like we said in our example, 2, and we go 1, 2, 3, 4, 5, 6, 7, okay, and then also one individual in generation 3, and then 1, 2, and 3 over, going left to right, 1, 2, and 3. Right? Now I did little points there. Okay? So now let's look at this one, number 2. Hopefully you see that. It's the ones that are shaded have it. Okay? How many children did individual 1, 1 and 1, 2 have? So 1, 1 and 1, 2 are found in the first generation. That's that Roman numeral 1. And then numbers 1 and 2. Of course, it's the only 2 there. So looking at mom and pop here, remember that the horizontal line is their relationship line or their coupling line. And so let's go down vertically. Oh, we've got more than one kid, so we kind of do this fancy chart, right? Now, this is where it gets fun. Only the ones that are joined into this chart by the vertical line is children. Now, don't get confused by a certain individual on here. So let's look at it. I'm just going to kind of mark it to show this is one kid, so one here. This is a two kid, two, three. Now watch this, 4 here, 5, and 6. So they have 6 children. Now you may be thinking, well, what about this person or this person? They're in this generation, but what about them? There is no vertical line, okay? That means they are married or coupled up with one of these children, okay? One of these, well, adult children or grown children, okay, in the second generation. Okay, so there you got that couple in line right there and right there. Now this individual here and this individual here is not biologically related to these individuals, right? All right, so let's think about that. So children, it's only the ones with the vertical line. All right, let me just mark through this and clear it off. So hopefully you can kind of see how they only have 6 children. How many girls, number 3, how many girls did 2, 1, and 2, 2 have? All right, so let's look at this. Sorry, I didn't get one erased. All right, so 2, 1 and 2, 2 will go to generation 2, and then individuals 1 and 2. Well, that's easy peasy. And we know they got a coupling line there, and then we got this vertical line going down. They have 1, 2, and 3 offspring. Now, how many of those offspring out of these 3 are girls? The circles, right? So 1 and 2. They have 2 girls. Now, also in there, how many of those have Huntington's disease? 1, because only one of those is shaded in, right? Not shaded, not shaded, shaded. So of those offspring, only 1 have Huntington's disease, just like old mom here. All right, so now this is a hard one. So this is just reading the pedigree. Hopefully you kind of figured it out. All right, let's try to work number 4 here. Take a minute and think about it. This is more family tree oriented, but think about it. How are individuals 3, 2, okay, so this person right here, and individuals 2, 4, so 2, 1, 2, 3, and 4, how are those 2 related to each other? You can go at it either which way. Let's start on the circle here. Well, 1, we know she's a female because she's a circle, okay? These are her parents. Dad and mom. So let's look. Okay, this mom is connected to this square somehow. They are on the same generation. They're both offspring of these 2. So think about it. Mom's brother would be what to this person, to this girl? If you said that's niece and uncle, you're right on. Okay, so niece and uncle. So what we can gather from pedigrees, this is the very basics. We're going to get a little more in depth with some assignments and things, but this is the very basics. What we can see is it's a family tree, yes, and we have a nice way of laying it out there and keeping everything organized, but we can also start to see how do these, people that have a certain genetic condition pop up over time. We can start to see how probability and Punnett squares look. Like, look at these, mom and dad here, 2, 1, and 2. One of them had Huntington's and one of them did not, and their 3 offspring, 2 of them didn't have it and one of them did. So we can start to think about, what are the, genotypes of these offspring. Well, we know this one sibling here, this daughter, D and Big D, she's got one of those because it's a dominant trait, right? Whereas both of these other, the brother and the sister, have to have little d and little d, right? So we can start kind of tying it back together based on, just probability and filling in Punnett squares. So we're using a lot of the information that we've had prior. Don't get too lost in the woods, okay? I'm going to give you plenty of opportunities